Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. Now, the next thing that is one of the 5 fundamentals of RF you must know is RF behavior. RF, as it moves through a space, has a particular behavior set. And these behavior sets include scattering, diffraction, reflection, refraction, and absorption. Now, we don't have to get too fancy into all the technicalities of it today. You just need to understand these basics. And the most important ones we see indoors are reflection and absorption, with some refraction and diffraction as well, but mostly reflection and absorption is what we think about. So reflection is the RF signal reflecting or bouncing off of some kind of reflective material that has a size greater than the wavelength. And so we're talking here about metal objects like filing cabinets, things like that. These can all cause reflection, and many other objects cause some level of reflection. Its reflectivity factor may be higher or lower, but some level of reflection occurs. Absorption is when, technically speaking, the RF energy is converted to heat. And so what happens is the RF energy converts to heat as it is absorbed, and therefore it is lost. This is why your microwave oven works, okay? You close the door, you start it up, and all of a sudden 2.4 gigahertz radio waves are blasted into the microwave oven. These radio waves are absorbed very well by water, and so the absorption is the converting of the electromagnetic waves into heat. And the end result is that your liquid heats up, or anything that has moisture in it that's in the microwave. Think about it like this. Have you ever noticed that you can take a glass of water, sit it outside, and if the light waves pass through the glass, it will actually heat up the water more than just contacting water directly? Well, this is in part because of absorption and refraction behaviors. Now, refraction is where the RF wave bends as it moves through a material. So it's going to change slightly. And the example I like to use with this is take a clear glass, put some water in it, and take a butter knife, place it in the glass, and look at it from the side. It will appear to you that the knife breaks in two at the point of the water. And so you'll see the part of the knife that is in the water appears to be at a different location than where it really entered the water. There's this kind of illusion that occurs. That's because the light waves are refracting as they pass through the water. And so refraction can also occur, slightly changing the path of an RF wave, and of course some absorption as well. Diffraction is how an RF wave may move around a large object and sometimes change direction. And then scattering is when an RF wave hits something a little different than reflection that is smaller than the wave and breaks it up and sends it in multiple directions. It's really many, many reflections of the RF wave. So why are these behaviors important? Well, they're the reason that when you put an AP in a room in a building, those radio frequency waves can get to nearly every place in the room and also other rooms, because they're reflecting around as they move throughout the space. And of course, they're passing through some materials as well. Now, the interesting thing is that this can be bad for old type of networks like 11BG and 11A, but it can be very good for new networks like 11N and 11AC, because these multiple signals give us this reflectivity that allows us to have multiple spatial streams, separation of data based on phases and other factors. So RF behaviors, key to understand.